Okay, college algebra, let's finish 1.3. The easiest thing you will do in this section is operations with complex numbers, at least the adding and subtracting part. Just imagine if I were an x instead, you would combine your like terms as the exact same we're going to do here. So when we have 2 plus 3i plus 3 minus 5i, we're adding 2 plus 3 to get 5, 3i plus negative 5i is negative 2i. And that's it. You combine like terms. That's all there is to it. My suggestion to you is if it's a minus sign, you're going to go too fast. Distribute the negative and turn it into a plus. So 3 minus 5i plus negative 6 minus 7i. If you are confident in your subtracting skills, go ahead. I will not stop you or count it wrong because it is right. But I would suggest distributing the negative and adding. So 3 plus negative 6 is negative 3. Negative 5i plus negative 7i is negative 12i. So in total, we have negative 3 minus 12i. Now, if you have an complex number plus a real number, you just combine the real portions. It's like there's a 0i over here. So 4 plus 5 is 9. I plus nothing is still I. And similarly, if you just have a complex number and an imaginary number, you just combine the imaginary parts. So 5 isn't combining with anything, so you just bring it down. This is 2i minus 6i, so minus 4i. Those should be free and easy points at any time. It gets a little more complicated with multiplying and dividing, so we'll go ahead and look at those. So just like when you're multiplying binomials with x, you need to use the distributive property, which some of you know as FOIL. FOIL only really works for 2 terms by 2 terms, so just be careful when using it, which involves distributing both terms to each one. So 2 times 5, there's a caveat though compared to variables, is 10. 2 times negative 2i is negative 4i. 3i times 5 is plus 15i. 3i times negative 2i is negative 6i squared. So negative 6i squared. So we've got 10 minus 4i plus 15i minus 6i squared. That is 10. Combine our like terms here in the middle, just like we would do before. Plus 11i minus 6i squared. In the past, this is where you would have stopped if these were x's instead of i's. And you would have just put the squared first instead. However, we know something about I squared. I squared is negative 1. So what happens when I substitute that in? We have negative 6 times negative 1. Negative 6 times negative 1 is positive 6. So we have 10 plus 11i plus 6. Now look what happens when I down converted the I squared. We now have 2 whole numbers that we can combine again. So this is really 16 plus 11i. So one interesting thing that happens, if you multiply a complex number by another complex number, you get a new complex number. It's kind of an interesting thing that happens when you're multiplying 2 complex numbers. Now, true to form, we'll skip number 21 and do number 22. 4 minus 3i times 5 minus 7i. And again, distribute. 4 times 5 is 20. 4 times negative 7i is negative 28i. Negative 3i times 5 is negative 15i. Negative 3i times negative 7i, negative times negative is positive 21i squared. Combine our like terms. We have 20 minus 43i plus 21i squared. And again, I squared turns into a negative 1. 21 times negative 1 is negative 21. So we now have two terms we can combine. 20 minus 21 is negative 1. So that's negative 1 minus 43i. Now, rationalizing complex denominators. This is something that I've actually removed from the homework and I will not test over, but I still think it's good to put in this video, so we'll do one of them. The idea here is in the past, when you had square roots in the denominators, they would usually force you to rationalize the denominator to where it's only a whole real number in the denominator. Well, remember, I is really a square root of negative 1, so I is really like a square root in the denominator. So we have to deal with that. And the way we deal with it, if there's two terms, so for example, if we had 2 divided by the square root of 3, with the square roots by itself, we can just multiply by the square root in the numerator and denominator and get 2 square root of 3. The square root of 3 times the square root of 3 is just 3, and then that cleans it up. That doesn't work when there's a whole number and a square root in the denominator, because as you can see, if we multiply them, if I get rid of the I by turning it into an I squared, then I have a 4i there by multiplying the I and distributing. So we have to do what's called multiplying by the conjugate, which is the same strategy for square roots. That is, whatever you see in the denominator, you multiply by the exact same thing with the opposite sign in the middle. What this does is it takes essentially this middle term here that we combine and makes them opposites to where when you add them together, they become 0. So what's the conjugate of 4 plus I? 4 minus I. So I'm multiplying by 4 minus I over 4 minus I. Distribute 3 times 4 minus I, we get 12 minus 3i. In the denominator, I'm going to have to use the distributive property. 4 times 4, 16. 4 times negative I is negative 4i. I times 4 is positive 4i. And I times negative I is negative I squared. So you see what happens here with these middle two terms when we do this, they cancel. So we get 12 minus 3i over 16 minus I squared. Remember, this I squared becomes a negative 1. So this 16 plus 1, because minus a negative 1 becomes plus 1, or 12 minus 3i over 17. And so just remind me, if you see these in the homework and for some reason I missed one, just send me an email telling me to remove them. But in the event you need to do this, this is how it would be done. And that is all for 1.3.